Welcome back, Year 10. This is our next video about rivers for rivers revision. So we're going to start looking at river processes now, but in terms of flooding. So we've looked at river landforms, we've looked at what a river can do to the landscape, and now we're going to look at kind of what rivers do to the landscape, but also to humans. So hydrographs are quite complex to get your head around at first, and it will take a few goes. So hydrographs are what we call a compound graph. It means that there's two graphs in one, just to really confuse matters. Maths and science don't ever use these types of graphs, but we need to use them. So there's two things on a hydrograph that you will end up seeing. There are bars, which represent rainfall, and there are also lines which represent discharge. So I'll start adding a few things onto this graph, just to kind of show you how it might look. So you can see on the left-hand side, you've got the bars. Now these bars do not link to the runoff and discharge. They link to the precipitation. And so you can see over time, over a rainfall event, a storm, that rain obviously increases, the amount of rainfall increases. And we understand that. So during the start of a storm, it's a little bit of rain. As the storm starts to increase in intensity, it gets more and more. As it starts to get really, really intense, you get more rain and then it'll stop. And so that's what the bars are basically showing. The line is showing how the river responds to that rain. So you can see here the line goes up and then drops back down. And that's because obviously a river is how the earth gets rid of water from its surface. So it's how the water goes from the landscape into the sea or the lake. And so the river is kind of like an artery to get rid of that water. And so over time, obviously the level of the river, or what we call the discharge, which is the amount of water in a river, will increase. Now discharge is measured in something called cumex, which is basically a meter cubed. So water going past a certain point, okay, is measured in cumex. So it's the amount of meter cubed passing one point in a second. And so the amount of cumex that are in this river here will increase over time as this water reaches the river. Now how it reaches the river we'll talk about in another video, but depending on how it reaches the river depends on how fast the river will respond to that rainfall event. So for example, if the water is stopped for some reason or it's slowed down, then this curve would not be as steep. But if the water was allowed to flow freely straight to the river, it would increase really rapidly, the discharge. So that's why you've got this type of hydrograph. And we'll look at the difference between hydrographs in a few minutes. So on a hydrograph, you've got a number of things that you need to understand. So we've got something called the antecedent or base flow, which is right at the bottom, and it's normally represented in a different colour, a slightly different shade of blue normally. The base flow is what the flow of the river would normally be at that time. So this here is the base flow line. And anything above that base flow line is technically storm water and could be flood water. So a river can hold a certain amount of water. Depending on how fast the river gets rid of water that's above that amount, depends on how quickly or if it will flood. So this line here, the yellow one that you can see on the screen, is the discharge line. So it's how much water is actually in the river at any time. And as I said, if it goes above this line here, the base flow line, then you're going to start to think, well, actually it might flood. We've also got something called the peak discharge. So peak meaning top, most. Peak discharge is at the top of the discharge curve. So it's here. And so the peak discharge for this storm hydrograph is approximately 47 cumex. You've also got the peak rainfall, which is the most rainfall. So this is where the most rainfall is. Now, when we're looking at peak rainfall and peak discharge, you can work out something called the lag time. Now, lag time is something that's commonly asked to explain or to describe and commonly asked to calculate. And to calculate the lag time, it's dead easy. You basically work out the difference in time between the peak discharge and the peak rainfall. And to work out the time, you look at the x-axis. You first of all work out what the peak discharge is. So the peak discharge here is around about, I don't know, maybe 1100 on day 2. And the peak rainfall here was about probably 1800, let's say, on day 1. So you'd work out the difference between those two to work out the lag time. In an exam, it'd be a lot more straightforward to work out the lag time. The numbers would be a lot more simple. So I'm not going to work this one out, but we will go through a few examples in class. You've also got something called the rising limb. The rising limb, obviously, where the water is rising, and then the falling limb is where the water is falling. You'll notice that the falling limb is a lot steeper than the rising limb, and that's because a river responds quite well to having lots of water in it. The more water it's got in it, the faster it will flow, and therefore the faster the water level will drop. But it does take a little bit of time for this rising limb, for the water getting into the river, to actually get into the river. You've also got something called bank full discharge. So at bank full discharge, and this is different according to different rivers, anything above that height, it's likely to flood. And so in this river here, you've got a likely flooding period, and it probably flooded for this amount of time. So I don't know, maybe 3-4 hours that river flooded, but then it went back to normal. Now what you've got to worry about when it comes to flooding is if obviously the bank full discharge is here and the curve is massively above it, and it's above it for a long time, that's when you're going to have long prolonged floods like we had in the spring and late winter, early spring of 2020. So hydrographs show a number of different things. So overland flow plus through flow equals storm flows, and this is your storm flow here. So the light blue, or the storm runoff, it's the amount of water that is more than the river would normally have in it, and that's anything that's above the base flow but up to the rising limb. You never normally have to work out the storm flow. Maximum rainfall during a rain event is going to be your peak rainfall. The time between the peak of the rainstorm and the peak flow of the river is your lag time. Normal discharge of a river is your base flow, or what we call the antecedent. Antecedent means before conditions, just a Latin word. Rising flood water in the river is the rising limb. Maximum discharge of a river is the peak discharge, top of the curve. And then the falling flood water is the falling limb. As I said, hydrographs are quite difficult to get your head around, and it is worth having a go and keep on going back at it over and over again, just to make sure you understand, especially these key words that are linked to it. Just to show you a couple of different scenarios. So, depending on where a river is and what the river looks like and the different conditions in a river depends on what type of hydrograph you're going to get. So I've just added on the hydrographs for these different river basins and river shapes and drainage densities and things, and I'm going to try to explain what they actually mean. So in terms of the steepness of the profile, the steeper the river profile, the faster the river is going to flow, and therefore you're going to get a really steep discharge curve because you're going to get water getting into the river really quickly. If it's a gentle profile, it means that it's taking a long time for the river to respond to the water getting into it, and so the discharge curve is a lot less steep. And so you've got a really steep discharge curve and a really gentle curve. In terms of drainage density, this is basically talking about how many rivers are attached to the main rivers, or how many tributaries are attached to the main river. If you've got no tributaries attached to it, that means that water is taking a long time to get to the main river. And so the discharge curve will be gentle, okay? But if you've got lots and lots of tributaries going to it, it means you're going to have loads of water getting into the main river really quickly, and the discharge curve will increase quicker because there's more water getting into the river quickly. In terms of shape and stream order means how many streams are attached to the tributaries in the main rivers. So if the drainage basin is really long and thin, well, it's going to take a long time for the water to actually reach its final destination down here. And so the discharge curve will be quite flat. But if you've got lots and lots and lots of rivers and joining, it means you've got more water, and therefore the discharge curve will be steeper. And then finally, the shape of drainage basin. This is quite a complex thing, but basically, if you've got a source area that's really, really thin, like this one here, narrow, triangular, I suppose, it means that you're going to get lots of water gathered really quickly from the mountains, which is normally where you get a lot of rainfall, getting into the river, which means that the discharge curve, as you can see here, will be quite steep. On the other hand, if it's quite wide and open in the upper areas, the water's going to take a long time to get to the river, which means that it's going to respond slower to the rainfall event, and so the discharge curve will be gentler. And then finally, if you've got kind of two areas of river, two drainage basins that kind of look like a figure eight, you're going to have two peak periods, and that's because you're going to have kind of a delayed reaction to a rainfall event happening in the upper area and a rainfall event happening in the lower area. And so it will have two kind of humps on it. There are two main types of hydrograph. This is just in closing. We get a steep hydrograph and a gentle hydrograph, and we give them different names. So the hydrograph A is called a flashy hydrograph, and hydrograph B is called a delayed hydrograph. Flashy for A because it is happening in a flash, it's happening quickly. Delayed for B because it's happening quite slowly. The peak is quite slow and the peak is quite fast for A. So graph A, the flashy hydrograph, is more likely to flood. It is more likely to be flashy as well. Quick response to the rainfall event, that's why we call it flashy. Have deciduous trees. Deciduous trees are like what we've got around here at school, so they drop the leaves. The deciduous areas are likely to have quite gentle hydrographs like in B, because obviously the trees will capture that water. But actually in the winter, it can become quite flashy because you've not got those leaves to protect the soil and to stop the water flow. Have little vegetation. Well, if you've not got much vegetation, you've not got much stopping the water from flowing through, so you're going to have a flashy hydrograph because the water's going to go straight to the river. If you've got permeable bedrock, permeable means it lets water into it and soak into it, kind of like a sponge. You're going to have a delayed hydrograph because the water is going to soak in, so the rock can take a long time to then get to the river. Have steep slopes. Well, we said already that that's going to be flashy. It's going to get the water there quickly. So that's going to be graph A. Be urbanised, like Manchester is, okay, and Flixton, Ermsted is. So it means you've got lots of concrete and tarmac and drainage channels and things. That's going to create a flashy hydrograph because you're going to get water getting to the river really quickly. And then be hot. Well, this is an interesting one because being hot can do two things. It can bake the ground hard, which means it creates an impermeable surface. So you could have an A, or flashy hydrograph, if it's baked hard soil, or you could have it as B, because it might actually, the ground might soak up the water, so it depends on the situation. As I said, hydrographs are tricky. Just stick with it, and hopefully you will get it. There's lots of 6-mark questions based around hydrographs, and again, we'll practice those in lessons. Thanks very much for your time. I'll see you soon. Goodbye.